Good morning, Year 13s. Hey guys, nice to see you. I know that we've just finished our Google Meet chat. I'm going to be really brisk today. We're going straight into Redox Part 2, Redox titrations Part 2. I know that we've had a nice 20-minute chat this morning, had a look at another question to reinforce what we did last time. I'm going to go through it again. So I'm going to share my screen. Let's get cracking on Part 2, because I've only got about 20 minutes to get this done. Then if I stop my camera, my laptop might crash. We will see what it decides to do. Let's go for device manager. Please don't crash. Please don't crash. Yay. Okay. Right. You guys should hopefully be able to see me now. Yep. Sharing screen should all be good. I'm not going to... Yeah, so if you want to make comments on the chat, please do. Okay, so what we've just done over our Google Meet is it was really nice to kind of run through another Redox question. And I just want to talk it through. I'm tempted actually to run it all the way through again. So because I can do it relatively quickly, the bit that I want to just comment on is the bit at the end with the suggests. So I'm actually going to leave those suggests in there because it's just a good reminder. Actually, no, I don't really need it. Let's see if I can just select all this writing and make everything vanish. Let's see if I can do that. Delete. I like it. Not quite perfect, but I think it'll probably do. Okay, zoom. Okay, so let's run through this one really quick. I know that we've just done it on the chat, but I think there's value in doing it again for the YouTubers. So, okay. Our learning objective today is recall the potassium permanganate and potassium dichromate half equations. Understand the role of zinc, that's going to be seen in question number 2, and know the ethanedioate titration. Okay, so this flags up as redox titrations because we're seeing iron 2 and permanganate in the single question. An iron 2 salt, which is in lawn sand, is being titrated against potassium permanganate. It's nice to remember our color changes as well. So the first step in any redox titration is to write down your half equations. So first thing is the oxidizing agent in this case is potassium permanganate, and the permanganate is then going to go to an Mn2 plus ion. You then weigh the half equation. Metal, manganese is done. Water, so H2O, we're going to need 4 of them, plus 8 electrons, and then balance for charge. We've got plus 7 on that side, plus 2 on this side, add 5 electrons. Yeah, okay. So there's our half equation for that one. Then we do our iron 2 plus is going to be oxidized up to iron 3 plus, balance that with an electron. Then, of course, we need to create our overall equation, recognizing that we're going to multiply this one by 5. So we're going to have 5 electrons. Oh, the electrons now disappear. Yeah, when we multiply this one here by 5, the electrons are going to vanish. Yeah, so we're going to have 8 H pluses plus MnO4 minus plus 5 Fe2 pluses going to 5 Fe3 pluses plus Mn2 plus and 4 H2Os. So there's our overall equation. Now the whole purpose of this is for the ratio. This is what I'm after. Yeah, I'm looking for the ratio between my oxidizing agent, MnO4 minus, and iron 2 plus. So in this case, it's a 1:5 ratio. That is the whole function. We had a quick discussion about the types of acid that we were choosing. Yeah, because the equation requires a large amount of H plus. And we had a quick chat about this. The only choice that you can make is for dilute sulfuric acid. And the reason for this is because you're allowed to do dilute because we need a lot of H pluses, but because sulfuric acid is diprotic, we get that from acid-base theory, the H that's going to provide us with 2 H pluses for every molecule. So dilute is doable. And the next thing is, of course, you can't use hydrochloric acid because the permanganate will oxidize the chloride ion up to chlorine gas, and your titration appears too large, and you make a toxic gas, which is not great. So now that we've got our ratio, what we can now start doing is use the data in the question. So it then said 3 grams of a lawn salt mixed with sulfuric acid. The resulting solution was titrated 25 centimeters cubed of permanganate. Okay, so we can now go moles of permanganate. So number of moles is C times V over 1,000. We're over 1,000 because we're in centimeters cubed. Our concentration was 0.02 multiplied by a volume of 25 all over 1,000, and I get an answer of 0.02 times by 25. It'll help if I turn my calculator on. Times by 25 all over 1,000, and I get 5 times 10 to the minus 4. So that there is the moles of potassium permanganate. Yeah, that were required in the titration. We can actually put that. That's MnO4 minus. Right, what we can now do is say moles of iron 2 plus. We know the ratio is 1 to 5, so we're going to multiply 5 times 10 to the minus 4. We're going to multiply that by 5. So I'm doing that on the calculator since the number's still there, and I get 2.5 times 10 to the minus 3 moles of iron 2 plus. Now, the key thing here is to remember that an iron 2 plus ion has the same mass as an iron atom. And the reason being is it's lost 2 electrons, but electrons are deemed negligible. 1.9 times 10 to the minus 34 grams, it's tiny. Yeah, they're really, really small electrons, so they really don't matter. So what we can now do is, we can now do number of moles as grams over rams, rearrange this, bring the rams over, so rams times moles gives grams. So I can now do rams, which is 55.8 for iron 2 plus, because it's the same as an iron atom. Multiply that by 2.5 times 10 to the minus 3. So I'm going to multiply my answer on my calculator by 55.8, and I get a mass of 0.1395 grams, which sounds about right. Let's have another look at, we had 3 grams originally. So we have 0.1395 grams in 3 grams. Yeah, I love it, per 3 grams. Multiply that by 100 and we're going to get our percentage. So divide that by 3 times 100 and I get 4.6%, which is 4.65%, which seems very reasonable, 3 significant figures. Now, just to let you know, it's nice to have a couple of bit of information here. Why would you put iron 2 plus into lawn sand? It is probably an anti-weed chemical. Anti-weeds or / anti-fungus. That's very common for them. Fungus really don't like heavy metals like transition metals like iron. So anti-fungus is probably the most likely, but also anti-weed as well. Weeds, although weeds are more resistant to transition metals than funguses are, but it still tends to be added. So we've got anti-weed and anti-fungus. The next thing is to mention that I said that I was going to comment on those key little bits of information that I mentioned on the extension questions, which is the suggests. Everyone hates these, and Redox titrations hit them a lot. So we've got suggest. Number 1, so if you look at the method he followed, he took his lawn sand, 3 grams, added it to dilute sulfuric acid, yeah, and then titrated the entire solution. Well, what that means is he did not repeat. So suggest why this would be unreliable. Suggest why this result may be unreliable. Be unreliable. Why might it be unreliable? Because he hasn't done any repeats. No repeat titrations done. So therefore not concordant. Yeah, you can't get concordance if you only do a single titration. Yeah, so if they haven't repeated, it's unreliable. We repeat to check that our result is reliable. And we know in titrations, whenever we repeat, the repeats that we do in a titration is a rough. So the repeats that we do is a rough at the beginning, and the rough one's always rough. It's the word rough is there for a reason, because it tends to be poor. And then we tend to do 1, 2, 3. You can actually, of course, what you do is you don't actually have to get to 3. Yeah, you just keep going now until you get 2 results within 0.05 of each other. Yeah, it's nice to just to recall as well. Accuracy of a burette is to 0.05 of a centimeter cubed. Anyway, so the next thing is that's the first suggest, and that's the practical aspect. That is a practical fault. Yeah, fault. So there is another reason why this is not reliable. The reason being is this lawn seed, this whatever it was, will have been exposed to air, and iron 2 plus is readily oxidized on air. So the second reason, this is number 1, the second reason is that iron 2 plus is readily oxidized, is often oxidized in air to iron 3 plus. What that means is, and I drew this picture out before, what this means is, if we had our lawn seed and it contained iron 2 plus, yeah, well, what it means is if some of it, and we know that what we're doing is we are adding an oxidizing agent to this. Yeah, we add potassium permanganate. manganate ions, it's easier to just deal with that, and it's better revision for you as well. So we add potassium manganate ions in a titration thing to turn them all into iron 3+. And we can use that titration to be able to quantify them. Well, if some of them have already oxidized in air, if this one had already oxidized to iron 3+ due to the air, then we're going to require a small amount of potassium permanganate. So it looks like our titration is too small, and therefore the percentage is therefore too small. So it's nice to mention these come up a lot, and you're going to see these in real exams. Okay, so next question. I've only got 10 minutes left, which is great. So let's move on to probably a more challenging one. Ammonium iron 2 sulfate crystals have the following formula. So let's extract information. So it's a horrible formula, isn't it? In an experiment to find N, 8 grams, okay, so we're going to need that. So we've got 8 grams of the salt is dissolved in 250 centimeters cubed of solution with distilled water and dilute sulfuric acid. A 25 centimeter portion, there's going to be a times 10 somewhere. Yeah, we know that there's going to be a times 10 somewhere. Was titrated against permanganate. Ah, how nice. It's nice to get our same. So at this point, yeah, and it tells us what it requires. So we can immediately write our two equations. Plus 4 H2Os. I'm weighing this by my Redox method. Plus 5 electrons. Right, Fe2 plus once again. Is it? Yeah, Fe2 plus in the compound is going to go to Fe3 plus. Now, the key thing here to remember, the key part that's important here is in this entire compound, yeah, there is one ion. So that there is an important fact. There is one iron 2+, ion in one molecule, or formula unit in this case, in one unit, formula unit of compound. So what that means is when we find the ion quantity, we're going to have the number of molecules there are. Well, that's going to be really on number of repeating units, the moles of it. Yeah, so we can put these now together. Of course, let's put these together. 5, 5, and 5. It's nice to see a good bit of repetition here to reinforce this. So 8 H pluses plus MnO4 minus plus 5 Fe2 pluses goes to Mn2 plus 5 Fe3 pluses plus 4 H2Os. Made a mess of that. My laptop's got a bit of a, I put on a screen protector and it's causing a bit of an issue. So ratio again is 1 to 5. Right, where's my titration? 25 of 0.015. Right, so 22.5 centimeters cubed of 0.015 moles per dm cubed. Permanganate. Right, let's work out the moles, folks. 22.5 multiplied by 0.015 all over 1,000. C times V over 1,000. Yeah, 3.375 times 10 to the minus 4 moles of permanganate. Right. Now, the thing is, we've now got the moles in the 25 centimeter portion. So what we can do is we can now, at this point, if we wanted, we could multiply this by 10. Now, we don't have to. We can use the ratio first. So multiply that by 5. You can actually do the times 10 in pretty much at any step. Multiply that by 5, and I get 1.6875 times 10 to the minus 3 moles of iron 2+ ions in 25 centimeters cubed. Right, let's multiply at that point. Let's multiply that one by 10. That's the fact that they took the entire solid and they added it to 250. Yeah, they added it to 250, but then they took a sample. So we need to multiply that by 10. This is going to give us the total moles. So this now is 0.0169 sig fig. Keep the number on my calculator though. So that is moles of iron 2+ in the entire solid. So how many grams did I have? Right. So I had that many grams. Well, the great thing is that is the moles of iron 2+. But what we now know is it is the same, yeah, equal to we also therefore have 1.69 moles of the entire ammonium iron 2 sulfate. Cool. So what that means is, I don't really want to have to copy it down, but I can. Ammonium. dot iron 2 sulfate dot NH2Os. Right, what we can now do is, because we've got the moles and we had the grams, we had 8.492 grams. So we also had 8.492 grams of this. Right, number of moles is grams over rams. But what we're looking for now is a value for N. And the way we do that is by working out its entire MR. This is the rams, or in this case, RFN in this case. So rearrange, bring the rams over, yeah? Bring the moles down. So rams equals grams over moles. I'll just put N. Sorry, next, right, so 8.492 over 0.0169. So I've kept that number on my calculator as well, 8.492 divided by answer, and I get a massive MR of 503.2. Right, now I can find out how much water's in it, because what I can now do, this is the complete MR, yeah, of this compound. Take away everybody but water. Yeah, so I'm going to minus, let's work it out. So what do I need to subtract? Well, I've got 2 nitrogens times 2. I've got 8 hydrogens. I know it's, by the it's way too, oh, wow, zoomed in. 0.0. Yeah, 14.8 times 8. And then sulfur, which is 32.1. Sulfur at 32.1, and then oxygen at 16.0 times by 4, and then iron at 55.8. Oh, can multiply that one by 2, get rid of him as well. Oh, and I can add in the oxygen to make that 8 as well, and I'm done. Right, so 14 times plus 14 plus 8 plus 32.1 plus 32.1 plus 16 plus 16 times, put it in a bracket on my calculator, plus 16 times 8 plus 55.8. So the total for this section is 284.0. Amazingly, it's weird. I feel like that shouldn't have happened. Should have been a 0.1 on the end of that. In fact, a point, yeah. Oh. Should have been a 0.2. That's weird. What have I gone and done there? That's, oh, the iron cancels out the 0.2. Lol. So minus 284. And what do I get? So 503. 503.2 minus 284 gives me 200. Make my pen a bit bigger. Gives me 219.2. How much? So water weighs 18. Divide that by 18. The answer is 12. 12. It says 12.2 technically. Yeah, but the answer is probably therefore going to be 12. Really nice question though. So obviously it's important then to check mark schemes in that. I mean, I'm pretty sure that's good. I don't like the 0.2 bit, but it doesn't really make an awful lot of difference. It's nice just to look at a mark scheme. I do have them somewhere. Redox titrations, which was there. And then I have my answer sheet here. So I'm looking for 12.2. 12. There we go. There we go. Nice. Yeah, I like it. So very reasonable. Lovely question as well. I'm going to end the lesson there. Next lesson. So I haven't actually done my learning objectives wise. I haven't done the role of zinc or the ethanedioate. So I will do one more lesson on that. I'm now going to post you guys these questions to do some practice on. It's way worth doing that. I'll end the lesson there at that point. Next lesson we'll do Redox titrations part 3 and I will be done. I need to turn my camera and then start count. Hopefully brings it back to the front. Yay. Right guys, I hope you found it useful. It's only a 20-minute one, quick one. I'll see you guys next lesson. Have a good rest of your day.